Yes, good day, class. I just want to explain one of the questions one of the students had with regards to the midterm. So, just for clarification, the question on the midterm was question 5, and the question reads, use graph paper to find the resultant of each vector. So basically, when you want to find the resultant of two vectors, you're basically adding the two vectors. So the first steps, you need to find the x and y values of each vector. So once you find the x and y values of each vector, you add the x and y values to get your resultant vector. So to find the x and y values, we're using the principle SO factor. So for SO, you know, for the y value, we're using SO, the sine theta equals opposite over the hypotenuse. The opposite of the angle would be your y value. To find the x value, we're using cosine theta is adjacent over hypotenuse. That will find the x component. And TOA is used to find the angle. So tan theta is opposite over adjacent, which would be the y over the x, would be your tan theta. And to find theta, theta will equal the arctan, so the tan inverse of opposite over adjacent. So that's the basic steps that we're looking to do. So first we need to find the x and y values of each of the vectors. So vector 1 is 20 miles at 3 degrees north of east. Cartesian coordinates, like we spoke about earlier. This is your east, north, east, south, and west. And this is your 3-degree angle, and this is the length of the vector, 20 miles. The second vector is 17 miles at 9 degrees. So 17 miles at 9 degrees west in a westerly direction of south. So this will be your 9-degree angle. But because we need to find the x and the y components, we need to find what this angle is because we need an x and a y component in order to form our right triangle. Right? So if this is 9 degrees, you know 90 degrees minus 9 degrees, so this angle must be 81 degrees. So this is where our right triangle will be formed. Right? So the right triangle is always opposite the hypotenuse, as Mr. Deal mentioned earlier in one of our earlier classes. And when you're adding vectors, this is the start of the vector, and that's the end of the vector. So you know vector A, it looks like this. And vector B looks like this. Right? To add vectors, you add the start of the second vector to the end of the first vector. So you would have something like that. Adding this would be A, and this would be B. The resultant vector is the initial start to where the addition ends. So this would be your R. Vector A plus vector B should look something like this. So we know that our resultant vector should be going in this direction. No, it should be looking something like this. Going in this direction, that will be our resultant vector. So our first step is to find x and y coordinates for vector A and vector B. So for vector A, to find the x value, I'm going to reset to find the x value, we're using cosine theta is adjacent of hypotenuse. So cosine theta, which will be your angle 3 degrees, right, from your initial question, is equal to the adjacent of the hypotenuse. You know the hypotenuse is 20. That's the length of your vector, right? So to get rid of the 20, we went through how to do that dimensional analysis. So basically, I'm going to skip those steps because you guys by this time should know how to do this. So 20 times cosine theta is equal to your adjacent angle, the adjacent side. So this works out to be 19.97 is equal to the adjacent side, which is the x value for A. So vector A for the y value. So for your y value, you're using SO. So sine theta equals opposite over hypotenuse. So 20 times sine theta, which is your 3 degrees, equals the opposite. So 20 times sine 3 degrees equals 1.05. So your x value x equals 19.97 and y equals 1.05. Right? So likewise, these values apply to that vector. We have to find the x and y values of the second vector, which is 17 miles at 9 degrees west of south. And once we find both vectors, then we add the two. So for vector B, the x value, the cosine of 81 degrees, worked out what this angle is equal to adjacent over hypotenuse. We know that the hypotenuse is 17. So 17 times cosine of 81 is equal to 2.66. For vector B, to find the y value, so to find the y value, we're using so. So sine of 81 degrees equals opposite of hypotenuse equals opposite of 17. 17 times sine of 81 is equal to minus 16.79. And we know that this is correct because this y value should be negative because it's going in a negative direction. Okay, so let's see. And also, this x value should be negative because it's going in a negative direction as well. So we have our vector B, x value equals negative 2.66, y equals negative 16.79. Okay, so we found out x and y values for vector A and vector B. Now we're going to add the two. So Rx, this is the resultant. This is the resultant is equal to x value of vector A plus x of B. So vector A is 19.97. Plus, we know that vector B was negative 2.66. So Rx equals 17.31. Ry, the resultant y, is equal to AY plus BY is equal to 1.05 plus negative 16.79 equals negative 15.74. Okay, so to find the length of, so this is your resultant vector, and this x and y values of the resultant vector, right? So to find the length of the vector, we're using this formula, which is c squared equals a squared plus b squared. C is your hypotenuse or resultant. So the resultant equals 17.31 squared plus 15.74 squared. So resultant equals the square root 17.31 squared plus 15.74. So R, once you do the math, R is equal to 23.39. So you know that your resultant vector of these two vectors, the length of it is 23.39. Now to find the angle, so we use torque to find the angle, right? So tan theta is opposite of adjacent. So tan theta is equal to 15.74 over 17.31. So this is equal to 0.91. So to find theta, you have to divide by 10. So this makes this tan inverse. Tan inverse of 0.91. So theta equals 42 degrees. So we know we have a length of 23.39 and an angle of 42 degrees. But we know that it should be in this quadrant because it's the RY value is negative from the previous calculations. So the Rx is 17.31. This distance 17.31. And then you come down on the Y value, negative 15.74. So your point should be somewhere in here. So this is what you're back to. Add the angle. First we have to determine the angle, which was 42 degrees. So the angle was 42 degrees. So we know that this is your point. And this is your angle. So your vector is just a matter of rotating around this. Remember, the vector goes from a counterclockwise direction, revolving around the x and y axis. Right, so that's right. That's what your vector should look like. So the angle is what, 42 degrees. And the resultant length is 23.39. So this is what your vectors should look like. So that's adding vector A plus vector B. So the first thing to do is draw vector A, draw vector B, find x and y coordinates of vector A, x and y coordinates of vector B. You add them, and you will have a resultant x and a resultant y. Use the resultant x and resultant y to find your angle. Okay, so now you can just apply this to the other two questions, and we'll discuss it next week.